Very welcome to be here. I can see from the list that most of you I know, I have met. This is a bit strange for me because I usually have presentations in front of living people. Now I do it in front of a camera, which is a bit awkward for me, I must say. Actually, first time I have a webinar, so you have to be a bit forgiving about this new technology. I actually prefer people, but this is the way it is now. So I am going to hold this in English because we will have a few friends from Europe here as well. I guess we have already a few. Yes, we have a few. So the topic of today is to talk about scalable and modular test systems and how that affects production and development in sort of ways. My name is Mattias Eriksson. I have been working here for Kestit and formerly AdQ for 15 years. I've been working with production test systems for about 25 years. So I have a bit experience in this field. So to reset the clock there so we keep track of time. And so I try to share a bit of my experience here. That was Sarah and the team asked me to do. So what will you learn today? Hopefully you will learn something. So the main topics of today will be why a scalable test system. And in order to understand the why, we need to understand what it actually is. And actually, this sort of why have a scalable test system? Well, it's a way of dealing with increasing production volumes. Hopefully, the volumes will increase, not decrease. And also, the benefits of having a scalable test system is that you can sort of develop it quite early and then later scale it up to a larger system. So that's always an issue that you perhaps, no, we don't have that kind of production yet. We need to do that later, but it might not be the case that you have needs to really wait. So production testing. So this presentation is going to be quite general, not too deep in technological stuff, because I know we have an audience that is, some of you are really skilled. I can see that some of you are more in the management area. So we're going to try to keep this as more of an overview. Test, really difficult word, probably something Latin, meaning unknown or something like that. I don't know. What I know about production testing is that we always deal with this one, a unit under test. We try to test something. And it's a typical hardware thing. Something that we build, we need to test it. That is the topic of today. So we're not talking about testing software systems here, like testing a new bank system or new insurance system or a new booking system, because that is more of a also testing, but that's sort of testing the versions or high load or something like that. This is sort of production testing, but we have some physical thing to test. I will use the word UUT, unit under test, if you hear that later. And a typical system for us, for us to test is a PCBA, circuit board, somehow. And also, when we have tested this, another really common thing is to test end of line. It's a final testing. That is actually when you take one or two of the PCBAs and put it inside some plastics and do a final product. That is a really typical situation for us. And I know also from the participate list that it's a typical situation for most of you also. And this is sort of involves a lot of things. We need that each unit need to be tested. But typically, when you have come that far to have a unit assembled and you want to test it, you typically need, this is actually typically the first time you even start it. It's the first time you even put power onto it. And typically you also involve programming on firmware. Not only test it, it typically come without firmware. And also, it could also be that you need to configure it and make a variant of it. Typically, that is the case of the end-of-line testing, that we need to do some variants, configuration, because they typically have a lot of common components like the same PCBA that you could just run different configurations on that board to make different behavior. You can disable certain software features that the customer need to pay for. You may have not assembled all circuit board. It could be a simpler variant, and you need to do some kind of configuration. For example, we have a car charger. You may tell the car charger, do you have 3 phases or 1 phase support? What kind of cable is mounted to the charger? Do we have a cable, not a cable, and so on. So you need to do a lot of configuration and variant treatment in production also, and you need to keep track of this. And before we actually reach the state of test, we have a lot of assembly in production. And we are typically involved in that as well, because typically when you do a test system later, you need perhaps make some other stations, and you need to deal with the information that are handled in the production, typically like work orders, because you need to keep track of that in the results. A lot of part numbers. You perhaps need to find the correct test sequence or tests for a typical part number. It can also be what kind of configuration you should put down on the unit depending on the part numbers. Part numbers control a lot of stuff in production, and it also controls a lot of stuff what then will be tested, of course, because it's one test doesn't really fit all. And the next thing you also have is the BOMO materials, is how you compose parts. That could be also need to be keep track on, and we can also need to know in the test what kind of subboard is assembled. We might need to read out the serial numbers of the subboards to keep track of everything. So a production test system is more than just testing. It's also a lot of administrative work to keep track of things and versions and revisions of things, so we really build the right thing. So, and also batches, of course, and a lot of serials numbers we need to be dealt with, because it might need to be scanned during assembly and keep track of serials for traceability. What have we produced, and can look up things like how are this unit consists of these boards, might need to be scanned. Some boards are intelligent that you can communicate and you can actually query the main unit of what is my subboard serial numbers, but for some stupid boards without communication possibilities, it's hard. Serials also involves a lot of validation, because typically involves a lot of barcode scanning. So we need to validate, is this the correct part they have scanned, and so on. And that is also a big thing to validate things, and you can do that with regular expressions, a lot of administrative things that needs to be keep track on. And then we come to one thing that is almost, as my experience that we spend a lot of time in, is just labels, because they can be put on the units before test. It could be so that the test will output a label, and it can typically have a barcode on it, or a QR code, or a data matrix or something. And this is something that it's quite easy not to forget how to deal with this, because the problem is that a lot of external persons, suppliers are involved in the barcode system usually. And it's something that you really don't plan for at start, and it should be, all right, we need a label, and it should be of some kind, and it's regulation, CE markings. It could be for a UK market, it could be for the American market, it could be some waste disposal symbols for batteries or something like that inside that need to be on the right label and so on. So we involved also a lot of printing, and it could be to an external system like Bartender or a cloud label system or something like that. So yeah, and also label includes a lot of validation, as I mentioned before, and typically is that labels of subparts contains of both part numbers and a serial number. And we also use the labels to identify types and variants of what we actually produce, and so on. And it can also be labels that are printed, putting on the box that is going to be shipped and packed in. But dealing with labels, how to handle this is a sort of a presentation of its own. So I'm not going to do that too deep, but it's a huge part of a production test system that sometimes quite easy to forget about, but takes a lot of time. And all of you that is listening to this have your own process. It's never the same. You have the same different kind of problems, but it's always something we need to adapt. So what do we have for challenges for production testing? Well, first, of course, always the cost. And you have an investment to do in a test system. And it's, of course, depending on the production volume you have. The more you sell, the more money you can spend on the test system. But for small series, it's really hard to do super good. You cannot really pay for a test system that costs more than you expect to earn for 3 years. That's impossible. So we need to see what that kind of investment can really give you for payback. And we also have time, of course. And then we have two different time definitions. You actually have the actual test time in production. How long time will it actually take to test it? But it can also take how long time will it take to develop the test system. So you have to keep track of what are we talking about here. But time is always an issue. Then we also need to discuss when you have test coverage. That is how much the functionality of the unit that we are produced are actually verified. I wish I could say that we test 100%, but we typically never do. So it's hard to know because some components are a bit hard to test good, like capacitors for voltage stabilization and so on, EMC things. That is hard to do because it's some things can be really expensive to test. So we say sort of, no, we skip that. Okay, that takes too long to verify each and every Bluetooth channel. We cannot really do that in production. That is not a thing. So we need to make it smart. And also testability. How actually easy is it to verify that it works correctly? A typical example is that when you do PCBAs, and if you put them together as a big product, the main purpose of the design is to make these like 4 or 5 PCBAs work together as a system, and the developers always put them together and as it was one big PCBA. But sometimes due to space and everything, it's hard to make one big. So you put them in parts, and then you just put them together, connectors and so on. So it will be easier to assemble, for instance. The problem is when you, for instance, do PCBA testing, is that you might just want to test one board that is never meant to actually be run by itself. It's not designed for that. It's not really good testability about that. So it can be really tricky sometimes to just take one board and test it. because that's how you actually produce them. You produce one board, one batch of these boards, and then you produce another batch of another board, and you don't pick them and put them together and then test them. You want to test them directly after production. It's typically hard. PCBAs are really hard sometimes to do this when they are designed for a system. It can also be harder for a composed system, is that you don't have really test software on it. It's hard to do low-level things. It could take time to establish like synchronization with a external network and so on. You don't have that time. So testability is something we really work with. Okay, you can build in a lot of test modes in the product. The problem is that it might not be the way the customer actually use the product later. So test mode might not really reflect how it works later. So it's a bit hard to make this really good. So what is production testing compared to R&D, research and development testing, lab testing? Well, production, not the same as R&D lab testing. That is typically, okay, it works in the lab. We have all heard about that, but it's a lot of things that differs. First, there are no really highly skilled personnel in the production. It's typically operators. I once heard a definition of how simple the test system should be. We want to take a butcher from the street. He said it was an American company. I don't know if there's so many butchers from the street, but I understand what he actually meant. So we just have operators that just put things in. They are not so skilled. You can take anyone, and they are going to perform the testing. So it must be really simple. We always test new assemblies. We deal with different production batches. There can be something wrong. We really don't know about if the parts works. As good as if you take one sample that you have in R&D, you typically measure on that over and over and over again. But here in production, we deal constantly with new assemblies and new unit on test. We also are in a factory environment. We have a lot of machines. We have sort of lifters going around, welding machines, noise environment, and so on. We also need to design the production to be easy handling. So it should be easy to mount. It would be easy to test. It should not be, when you do a lab setup, you can connect and you can spend like an hour just setting up the test. You cannot do that. You have a few seconds in production if you want to keep test time down. And also you need to have a sort of a test setup that deals with this easy handling. And so on. So that is something that really, really differs. And of course, the factory could be in another country. And that is also a really challenge. It's not so easy to just go in and measure. It's not always that you actually have everything in hand, especially then you have just like a few days setting everything up in a factory. If you go to a different country, that can have different voltage levels in the factory. Other kind of machines and so on. Can be language issues, hard to explain things. Documentation might not be really in place, especially at production startup, and so on. So, what is production testing all about? I typically say it's find the units that deviates from the other. So, it doesn't really super important that you measure exact the value of an output that it should be, if it's not a really critical feature of the unit, of course. But it's mainly about finding that the units that deviates from the other. So I usually say that production testing is one big trade-off. You need to have a fast production. That you cannot really measure as good as in the lab. You need to have a way of dealing with the production. You need to make it so simple to hand, so it's have to be good enough at a fair price, and that is hard to do. If we have how much money as we can, a lot of time, yeah, sure, we can test it really good, but we never have. So it's a big trade-off. That's sort of lesson learned. So you need to keep that in track. We can never get it as good as in the lab. And production testing also involves a lot of factory integration. We have our test system, yes, but we also have our manufacturing line before that needs to deal with something. And after the test system, we typically have packaging. And that means that we typically are dependent on what happens before the test system. From the manufacturing line, we can make sure everything has the correct labels, assembled correctly, so we actually know that the test we are trying to run actually match the assembled unit that is going into the test. So how do we do that? Typically, we use the labels and serial numbers and article numbers. And of course, we need to have the packaging afterwards. Maybe we need to print some labels. We need to output some information to the packaging system. What is this kind of batch? What is the firmware that we are printing or putting inside this one? Can be on the packaging label. We can need to have like a scanning system that we check that everything that is packed is actually passed the test. One thing could be that you, in the manufacturer line, put the serial number label on, just with the article number, serial number on, and the test system later is putting on a second label, like a type label or another label. So you can actually see when it goes out from the test system that if it has two labels, it's passed. Or you can have a system that scans the unit that sort of automatically check that it's okay before it's packed and so on. So it's endless kind of possibilities here, but typically is that we really need to interact with the other things in the factory. And also that includes some kind of manufacturing execution system, that you have some system in the factory that we want to get information from, and the test system might output some information to that one also. So it's a lot of other things, but the test system that we need to deal with in this one. Yes, so yes, and of course then we have our solution for this. It's what we call the CAT system. It's a test platform, a software system that I will come back to later to deal with these challenges. So what is a production test system? The first thing that comes to mind is perhaps just some hardware. A typical test station. That's what you see when you have a production test system. That is the first thing that typically comes in mind. But this is a quite large station with a lot of hardware. And what does a station consist of? Of course, instruments. This one, I think, have some kind of power supply. It has some kind of multimeter. It might have some other things, computer, yes, of course. And it also deals with a lot of communication, both with controlling the instruments and also controlling the test object. Everything that we try to test on today usually have some kind of communication interface. There's almost always a microcontroller on board. That is so common today in everything. We deal with a lot of connectors and interfaces, especially since as you remember, we are testing each and every unit. We switch units all the time. Okay, if we have a production volume of 100 a year, that is maybe not that big issue. But if we have like 100,000 units a year, then we really need to consider the connection of the test to be tested, test unit. Another thing, we deal with safety. We have a lot of units that are running on AC voltage, 230 volts, that we need to protect the operator and the humans, and we deal with a lot of CE markings and so on. This particular hardware you can see here, I think it has light curtains protecting around, so it immediately turns off things. It can also be things like not only electrical shock. We have it could be a test object with bright light. We need to protect the operators from light. It can be sound. We work a lot with 3M in Värnamo for ear protection, and we need to have a silent environment just inside. And also we deal with a lot of noise inside, and we also need to protect the operators, so it's not will be a really hard environment to work with all this noise. And also could be the working height of how the operator stands. It's easier for us that are working in an office with a high and low desk that we can control, but you can also want to do with that in production. You can raise and do everything, because you are working there 8 hours a day, and it's quite hard to it's an important thing about the hardware, not only the instruments. Typically there's some kind of barcode scanning to get information about the product. You don't want to hack it in, because then it's a lot of problems with mistyping. And of course, typically a label printer could be there as well. Somehow need to be controlled. And the station usually don't run without some kind of test station software. And the software deals with instrument control. Yes, obviously. Communication with the unit under test, also really important. It executes the tests, both as test sequences and some kind of test steps. Whatever software you choose, you probably have some kind of test sequence that it will step through. And then you also deal with requirements. Also, what is the limits of the pass-fail or other parameters that you need to control. And that could also be quite tricky to keep track on, because if you change, you want traceability in how you change requirements. You need to have perhaps different requirements depending on different variants and different article numbers. And keeping track of requirements and traceability, who can change what and so on, is something that we deal a lot with for all customers in all systems. So it's a challenge to get a good system for that working. And also, not only requirements, but also the firmware and configuration to put on. We can have the best test system that is so good at programming Unity, programs a Unity in just 1 second. Really good. Programming is successful 100% all the time. And we produce like 10,000 units an hour and ship them with the wrong firmware. And it doesn't really depend. You really need to make sure that you are using the right versions in production and using the right configuration, so that the thing that you actually output from the production line actually is what you really want it to output. So it's much more than just technology, electronic things that need to work and so on, but the administrative part is almost more important than the actually how it really works in the physical world. And you also need to deal with a lot of traceability, and that is not only of serial numbers, what article numbers are you testing, the dates and so on. You need to deal with traceability of what is the instruments you actually have used. So you notice the serial numbers of all the power supply, so you can get a calibration certificate of that one. So you have traceability. Okay, I use this station, this was the instrument setup, and so on. So you can look them up later. So traceability both in the test object, but also in the station itself. It's important. So what is happening when you're scaling up volumes? Yes, that was one of the deals today. Typically, you start with a small test fixture. That is something that you can do really early in the development process. It's not that hard to replace. The cost is not so high, so you can make perhaps one simple fixture, do that early in the project, try up. And if you want to scale up production test, you can perhaps duplicate it, or you can sort of, okay, let's have a slightly larger station that we can do, or you can scale up something like that. So You can start with this and sort of scale up, I guess, maybe either to this one or this one. Don't think it's so common that you go there or there if you don't have two different kind of production lines, so on. Or you can go all the way to more fully automated test systems where you have you load a rack of panels, for instance, for PCBA testing, and then you can have a more of an automated system. This is more common for PCBA testing because it's easier to deal with PCBAs. It's a bit harder for end-of-line testing where it's typically larger things. You need to have more manual treatment and handling and mounting and cables and so on. It depends on the production volumes, of course, but typically we automate PCBAs like this, and not so common for end-of-line testing, depending on how they look, of course, because they can look really strange sometimes. So this is what scaling up is in volumes, but scaling up production is not only volumes. It can also be scaling up in complexity. You get new products. You have a production development. It's okay, we want new features from the marketing department. And we may have these new features, may need new instrument resources. We need to measure these things that haven't existed before. We can also scale up because we want to increase volume by doing parallel testing. Let's test 4 at the same time. Really common for PCBA testing. But that really adds complexity also because it's now you're trying to do it on 3 or 4 or maybe 16 units at the same time. You really need to deal with, okay, what happened if that one fails, if that one is not mounted, and so on. It's a more complex production test. It's so much easier to do for one single test. The UT may have new communication buses, new way of communicate. There can be new, it should be IC with the capital C, new microcontrollers, because sometimes there's a really short time that the microcontroller lives. So you have to constantly replace them, and that might require new programmers, new communication interface, and so on. And also security. It could be that we need to put some security keys in. We need to get certificates from some cloud service and so on. So everything can be really complex in a system after a while when it keeps running. So you need to have this back in mind. So typically what we're talking about, we need some kind of platform for our test in order to deal with all these scaling things. So I just thought, let's look up what is a platform mean from Wikipedia. It says it's a raised level surface on which people or things can stand. And this is the picture. It might not be the kind of platform that we need in production. Maybe it's good for the workers to get in time to the work shift. That's correct. So I keep looking, and the platform can also be a shoe with very thick soles. Might not be the things that we are looking for. But so the question is, to platform or not to platform? So let's see what we really have here. So let's go. So I specified my search bit for test platforms instead. Now we're dealing, okay, now I need to get some good examples. So the first thing I get was this one. Okay, that test platform might be a bit large for most. I don't really think that fits the audience here today. Quite fun to work with, I guess, but it's a bit large, so I keep searching. This was also some kind of test platform, and this is also some other kind of test platform. And here's my favorite. You could just click a button and you get a new test platform out of the blue. So it is a bit vague how you define the test platform. So let's see what we have here. This is perhaps more of a hardware platform, is more than you perhaps have a fixture-based architecture in your hardware. Then you can have the station as a sort of a platform, and then you can just replace test fixtures depending on the product you're testing. We use a lot of fixtures that has VPC, that's Virginia Panels Corporation. It's this kind of connectors that you actually see on the picture up to the right. And then we can put some kind of fixtures in this. This particular fixture will not fit on that one. It's a different kind of fixture, but I didn't find any good place. So when you are designing a hardware platform, it's a lot of things you need to consider. The most common is that you have some kind of fixture-based architecture to reconnect or reuse the instruments because they are quite expensive. You need space for more instruments. That's important. Don't fill it up directly because then you don't have any way of extend things. You need to have spare signal places in connector interfaces. For this example here up to the right, you can see we have 3 spare slots, really good, that we can use for extend systems. It's also, if you're going to extend a hardware platform, make it maintenance friendly. You have a bit room to work and so on, quite important. And also you need to have really good documentation. That's important for all, but especially if you're going to build a platform, extend the platform, keep it up to date. It's so common that you do changes, you just do them on paper and you never put them in. So always put them up to date directly. Then you know that you can always trust the documentation, and also make everything, mark everything inside the fixture so you don't have just cables everywhere. Some system for this is really important when you're trying to build up a hardware platform or any hardware by that deal. But there are problems when you are having this hardware platform concept. This hardware platform has some serious problems. I hope we don't get that kind of problems in our platforms, but when you have a hardware platform, you always need some kind of interface because you typically replace something. So you need, just like a VPC things, you need to have something good that you can connect. And connectors cost money. It's not free. It's one of the most important, expensive parts of the system. It might end up that you design a station that perhaps has more resources that you actually need. You plan for future things that might never happen. You typically end up with a little bit longer cables because you put the instruments inside a bit away so you can reuse them. And long cables are not really good when you're measuring. Depends on what you're measuring, of course, but it's usually not so. We deal a lot with too long cables, especially for high communication buses. And also when communication buses need to go through a connector somehow. And you need to somehow predict future needs. Could be a challenge, actually. And that's difficult. And you might end up with resources that may never be used. So I have an example here of cabling issue. We have a 19-inch rack to the left, where you can see where we have all the instrument resources, and we have the test object to the right on the fixture, and in between we have a exchangeable fixture. And we have a lot of switching in this system, a lot of relays and multiplexers and matrix, and we need to wire them together. And you can see from the track here, so when we have an instrument here and try to measure a specific test point, we ended up with 6 meters of cables when the physical distance is about 40 centimeters. So it's easy to do these kind of things that you might not be aware of. It's on paper really flexible, but you have to consider what it's actually can be. So why use a hardware platform? cost effective. If you have a lot of different products you need to be tested that are quite similar, you can really share resources. That's probably the main reason for this one, because it reuses resources. And if it reuses resources, you typically reuses the software modules that is used to control the instruments. It's quite easy to duplicate stations because you typically put in some efforts on this test platform. So it's all about making the right trade-offs. You need to find a platform that's sort of balanced from your needs, the cost, and so on. But it's not always possible to use this one. So why not use a hardware platform? If you don't have a real hardware platform, you sort of design one system that is just going to fit one product. It's going to be simpler. It will be shorter cabling because you can put the instrument as close as the test object as you want. Typically, it will just use the instrument you need. It will be cost effective. You only need the resources you actually have. It will be good. And you don't have to predict the future so much. But it can also be a problem when it's changes to the product. It might not be so hard. So here's an example of a system we built a few years ago. It's just a box with some instrument resource directly. It has no fixtures. It will only fit this kind of test object. And we cannot really reuse it if they do a new model, change any connectors, nothing. So, and we have to duplicate everything if they wanted to make another copy. But it was if you just want one quick solution, this is an option. So it's always an option to do this. So what is production testing also? We need to scale up production testing in order to support all these kind of different test platforms. We need usually what we call a software platform. And at Kestit and formerly AdQ, we have worked with a system that we call CATS for at least 15 years to deal with all these things. And it's one thing it's really good at is parallel testing. It has a modular plugin architecture, so we can sort of set up the platform quite fast. We can add instruments. We have a lot of instruments that we usually use, but it's quite easy to put in instruments that we have never controlled before. One thing that we always have we need to develop for a customer is communication with the test object, unit under test. We can also deal with remote control. Either we can have this as a manual GUI where the operator pushes the button and run. But due to the plugin architecture, we can do monitor systems that are listening for PLC communication, so we can get this inside an automatic line, for instance. We have plugin architecture for configurations. Like default, we use some kind of XML configuration, but we can do it as a Python configuration. We can query other kind of administrative mesh systems for information and so on. And the same on the other end, we can do some kind of result exporting also out of the system. We have our own QRM systems that you've probably heard of, but we can export to plug in as many result exporters as we want. If the customer has some special system or factory system that we need to export to, we can just add one of these modules to our system. Make it easy. So why use the software test plan? Of course, we can reuse. That word should actually be debugged. Hopefully it has been in use for a while and we don't have so much bugs, but it also have a debugger. Also, it's faster to set up a new product. The first project may take a bit longer time, but the second project will take much more less time. We need to produce less new code, always good. Usually a test platform is have some kind of extendability and scalability that we can support single testing, parallel testing, add new modules, add remote control modules, reuse the same kind of test and so on because of its plugin architectures. And for us as a supplier of test systems, it's much easier for us to have share resources between product. It's easier we are now like 15 people that knows our platform, so it's not that hard to shift people. If you have different platforms all the time, it's hard to really fix things between and so on. It's easy for us to, okay, can you go in and see why the instrument doesn't start? Because then we know where to look and so on. So it's human resources, it's easier to deal with. But there are problems with software platforms, of course, as everything you do that is quite smart. It increases complexity, no doubt about it. It's easier to do one code that just control the exact instruments we have, communicates with this unit on the test, and just outputs one kind of result that we want now. Yes. So a platform with this plugin architecture, of course, increases complexity. So you can end up with some configuration that is it's a hard bit to know how to do it, and it can be hard to know how to do it correctly. And it can also be a higher initial costs if you want to develop one from scratch. But if you, for instance, use one of ours that we had done for many, many years, for us, it's much easier for the customer to use our platform because we can do it a much shorter and quicker time. So for the customer, it will be lower cost compared to if he had to directly build up their own system. So it depends on how you define that. So we have, of course, our CAS platform to solve this that we work with all the time. And it has support for parallel testing, plugin architecture, instrument configuration, results, manual remote execution also. And it also keeps track of all the instruments and serials automatically for this one. So you have some kind of extendable software platform here that sort of make things easier to scale up. So we have what you typically have is that you have the platform that we have in the middle, and then you have some kind of test methods, UT communication and equipment that deals with the test object. Obviously, that's the reason why the test platform exists at all, is going to be used to test some UT. So you typically have parts in the system that communicates with the test object and also communicates with the equipment that is going to measure on the unit. And we typically use some kind of test methods to control this. We can also plug in some kind of monitors where we can have some process in the background, having some monitor things and show things even if when you don't run test. It can also be some kind of safety monitoring that we need to perform. Have the operator really closed the fixture? Can we really put on 230 AC until the operator have closed the fixture and it's been locked properly? So that is something we can do. We also have adaptations towards the operator. We need to deal with all the labels, format of the scanning of the barcodes and so on, and how should the operating interface look and so on. We need to put some configuration to the system, either from configuration files or we have our QTM system that is used for dealing with the input to test platform as a support system. We need to deal with the output of the systems. Typically, we need test reports somehow. We have our QRM system, but we can output to any kind of system as long as we know the format of that system. And sometimes we need to go in a high level of automation. Maybe this system should be inside a production line where it's fully automated, controlled by the manufacturing line. So we can add some remote control through, for instance, a PLC controller or something like that. So this is typically what we have in a complete system. But we need also support systems. So typically we have support systems or need for inputs to the system, because we need to have test management. We need to get the requirements somewhere. We don't want to hard code that in the code. That's not so good. We need to have information about the articles. Typically part numbers, the bill of materials, how it's composed, or which parts numbers are part of another part number. We need to deal with settings, could be configuration settings that we need. Okay, for this particular part number, we really need to write down to the test object that, okay, you're a 3-phase car charger, you're a 1-phase car charger. You are a smart Bluetooth headset with dual communication channels for operator, or just one, for instance. We also need to get which firmware version should we use to flash down to the unit, so we get that right. Really important things that we need from a test management system. We need the test sequences, parameters, and requirements. We also need some kind of administration for the actual test software, the CATS platform build. So we have that in place, because there are developments, new support, bug fix, and so on. It's always good to have some kind of system to deal with this, because it's usually also, because this is running in production, that it's usually somewhere else, not in the basement. It could be in another country like Poland or other side of the world. So it's good to have some kind of overview what are they running. And also nice to have some kind of monitoring and synchronization, so you actually can have some kind of feedback from the test stations. Okay, have this station really synced down everything we need on the station? Are we sure that they are really using this firmware, so we don't get a nice surprise when they ship it to the customers and no, this unit has the wrong firmware, but we released the new firmware. Yeah, but there was some problem with the internet, so we never fetched the user, and we never get any feedback. So some kind of monitor system could be really nice to have also. And then we also have the output. Typically is that we need to deal with results, test reports. We need to deal with the serial numbers of the test objects to connect them to reports, but it can also be that we need to track which unit consists of which parts. So we have this unit has this logic board inside, or this power board inside, so we can keep track on that one. We can also need to keep track of settings. Maybe we have put a password on this unit that is unique for this unit. We need to store it somewhere, and that could also be stored in some kind of output systems where we can deal with, okay, this unit has this password that we can look up in some other systems later, perhaps. Test reports, of course. From some kind of these systems, you also need some kind of production reports where you want to perhaps check yield, first pass yield, how many have you produced, and so on. What is the trends, and so on. That is sort of another presentation for another day. You can talk about that for hours. You can do some statistical process control, where you can see how is the normal distribution of one measurement going inside our requirements. Do we have any trends, any drifts, and so on? So to solve these kind of problems, we have worked with first QTM, that is an input systems, deals with all the articles, part number, boom, settings, and firmware. You can define test sequences, parameters and requirements, deal with the test software administration, do some monitoring and synchronization, define stations to publish software, publish firmware, publish certain articles to all the stations in order to keep track of this. And you also get feedback. So this tries to solve a lot of things that we have issues with in production. Typically, we can have an overview wherever the stations are located in the world, because that's a huge problem. How do we know that this station in this factory is actually updated? So we actually get full control over the station's activity. We can keep them in sync because we get feedback, so we can instantly see if they are offline or online, we can see that they actually have synced down. It compared checksums. It also may encrypt things that puts on the stations, like firmwares, files, settings, and keys, so that we can keep encrypt on the station in order to keep it safe. And everything is tracked by log, so we can see, okay, when we publish this firmware, when we did do this, and so on, because that's also a huge problem. We have to backtrack things. We also have our QRM, quality result management system, that we are used to keep track of test reports, UT tracking, the settings, the parts, the serials, of course, production reports, and yield analysis, repairs we can do also, and a lot of statistical process control. We are now in the full way of developing next version of QRM, so we have one guy working full time on this. So we're going to have a new release this year with a complete new web interface and a lot of new analysis features. It's going to use the same database in the background, so it will be 100% compatible with the old one. So and it can ride side by side. So it will be a huge improvement in performance, what you can do. You can build up your own dashboards and so on. We will have more buzz about this, I'm quite sure, Sarah, this year. So we will work on that really much, and you will hear more about that. So to conclude this is that you remember that we had our factory integration look like this. So if we can build the systems our way, is that we are adding the QTM and we are adding the QRM system. So okay, if we're back here, so why don't you use the mesh system here? It typically have the same information as the QTM. Yes, correct. It does not really have possibilities to monitor and synchronize, but you can have typically article numbers, boom, parts numbers, and so on. But the problem is, from my experience, is that it's not that easy to integrate these systems. It's hard to query them. It's hard to get the correct information. It's always something that is not really good. Now we don't have support for that. Yes, it's more common that you can actually produce some result reports to that system, but we usually use QRM also in parallel, so we can actually export to both systems. So that was all I have today. We are just about time, 1 minute ahead, so thank you. Did we have anything in the chat or any questions? Any quick questions? One question. Challenges going from low voltage testing to high voltage testing. Yes, that is where the safety come in. You need to build up a safety systems around, so you can really break voltages, and you need to isolate things. But it's not that hard. We do that a lot. And we have pictures that are combined, so we can either use safety or not safety. So we deal a lot with that for that. So that is one big part, but that is something that you really need to consider when you're building up your test platform, because that's not so easy to just add at the end. So definitely important. But we typically use a safety relay inside the system and so on, and do a full of because we're not allowed to use them in production if we cannot really deal with that one. So that's really super important. So, yeah. Anything else? No, we are out of time, and I really thank you for taking the time today, and hope to see you on the next occasion. I don't know when it is, but it's sometimes. And thank you. Bye.